Hi, this is chapter 5, question number 41, and the question states, a 3 kilogram block starts from rest at the top of a 30-degree incline and slides a distance of 2 meters down the incline in 1.5 seconds. Find A, the magnitude of the acceleration, B, the coefficient of kinetic friction between the block and the plane, C, the frictional force acting on the block, and D, the speed of the block after it has slid 2 meters. So first we want to list our givens. Our givens are the mass of the block equals 3 kilograms, the angle of the slope equals 30 degrees, the distance of the slope is 2 meters, and the time it takes the block is 1.5 seconds. So first we want to start, and then we're going to find, in this order, the acceleration of the block, the mu k, which is the coefficient of friction, the force of friction, and the final velocity of the block. So first we'll start by looking at the diagram. We know that the length of the slope is 2 meters and the angle is 30 degrees. And so we want to start out by drawing a free body diagram of the block on the slope. So we know that the mg cosine theta is the force of gravity on the block, and it is opposed by the normal force of the slope. And then in the x direction we have mg sine theta, which is the acceleration of the block down the slope, and it is opposed by the force of friction. Now for the first part we're solving for acceleration, so we need a formula, and that formula is x equals 1/2 acceleration times time squared, and we already have time and x, which is the distance, so we can solve for a by isolating a by itself, plugging in the numbers that we have, and we come to 4 over 1.5 squared. Multiplying that out, we get the acceleration, which is 1.78 meters per second squared. Now before we solve B and C, it's important to note that the force on the block is equal to the normal force plus the frictional force plus mg, and that is all also equal to mass times acceleration. In the x direction, the frictional force equals mass times gravity of sine theta, theta is 30 degrees, minus the acceleration, since acceleration is down the slope, and the force of friction would be up the slope. Now in the y direction, the normal force of the slope is equal to the mg cosine, which is the gravitational force. With B, we're solving for the coefficient of kinetic friction. That is the force of friction in the y direction over the normal force, and using the formulas that we just saw in green, we get mg sine of 30 degrees minus a over mg cosine of 30. Now if we want to write this all out, sine over cosine is equal to tangent, and m cancels out, so we get the tangent of 30 degrees minus the acceleration from the top all over the denominator. Multiplying all this out with including a from part A, we get the coefficient of kinetic friction is 0.368. Now it has no units because all the units cancel out in the problem above. Moving on to step C, we're solving for the frictional force, and that's even easier because we already used the formula that was in green from above, so it's mg sine 30 degrees minus a. Now plugging in acceleration for that and solving it out, we get the frictional force is 9.37 newtons. Finally, for part D, we need a formula to solve for the final velocity. Now, we know that v final squared equals v initial squared plus 2 times acceleration, x final minus x initial. X final minus x initial is basically delta x, and we know delta x in our problem is 2 meters. Now, with an initial velocity of 0, we can plug in our 2 times the acceleration times the delta x, and we find that that is 7.11 meters squared per second squared. Now if we square root that to get v final by itself, we get the square root of 7.11 as 2.67 meters per second, and that is your final velocity.